Hello everyone, this is Aya, and today, along with my partner Nada, we are going to present our research paper entitled Music Therapy in the Era of Artificial Intelligence. This presentation starts with an introduction to music therapy and the need of AI solutions. Then we will discuss varying AI techniques and methods used in music therapy, followed by applications of AI in music therapy proposed in the literature. Finally, we discuss the challenges and future directions of AI applications in music therapy and conclude our research. Music therapy is a non-invasive therapeutic intervention that uses music to address physical, emotional, cognitive, and social needs of patients. Clinical experiments have reinforced the value of music therapy in various settings. For example, music therapy is used to treat a wide spectrum of physical, mental, and cognitive disorders. Physical disorders include hypertension and hypotension, breast cancer, and tinnitus. Mental and cognitive disorders include anxiety, insomnia, sleep disorders, ASD, ADHD, early childhood trauma, Alzheimer's, Parkinson's disease, and dementia. Although music therapy has become widely accepted and recognized, some limitations remain unaddressed. For example, existing music therapy techniques target a wide spectrum of cases using the same music and techniques, do not sufficiently address individual difference. Moreover, the current techniques are labor-intensive and time-consuming as they require the intervention of professionals. In addition, the cost of one-to-one music therapy sessions is high. Furthermore, many existing therapeutic techniques do not have sufficient methods for evaluating and monitoring the process. To address these limitations, the integration of artificial intelligence has been proposed as an aiding technique in music therapy. Artificial intelligence refers to the development of computer systems that typically require human intelligence to perform. AI encompasses a range of technologies, including machine learning and deep learning models that can perform complex tasks. In the music industry, AI has been integrated into a wide spectrum of applications, including music composition, generation, classification, recommendation, and music education. In the context of music therapy, the integration of AI has broadened therapeutic modalities, addressing the limitations, making therapy more effective, feasible, and personalized. With the empowerment of AI, music therapy processes such as diagnosis, treatment, as well as monitoring and evaluation has been improved. To this end, our contribution is a survey paper that provides a comprehensive review of the applications of AI in music therapy. This study aims to highlight the state-of-the-art methods in music therapy. We discuss the limitations of the existing conventional methods. Finally, we discuss the potential future areas of research in this field.
We review and discuss the most common techniques, namely emotion recognition, music synthesis and generation, as well as AI-driven recommender systems. In the majority of the reviewed research body in AI applications in music therapy, emotion recognition was often employed to enhance the personalization and adaptation of therapeutic music. Several approaches were proposed for real-time emotion recognition, including vision, biometrics, and speech-based approaches. Vision-based approaches utilize the visual input of cameras to determine the emotional state of the patient by analyzing facial expressions and body language. These inputs are non-verbal cues that are strong indicators of the patient's emotional state. Biometric-based approaches utilize biometric data like heart rate, EEG signals, or blood pressure to gauge stress levels and emotional state. Speech-based approaches analyze patients' speech, voice tone, pitch, and rhythm for emotional cues. Typically, AI models, specifically machine learning models, are used for emotion recognition. These models include support vector machines, SVMs, decision trees, random forest, KNNs, and AdaBoost models. Deep learning models are widely used for complex applications that require advanced pattern recognition, feature extraction, and generative capabilities. In the context of therapeutic music synthesis, deep learning models have the ability to capture the pattern, sequence, and melody from the large datasets of music and utilize the extracted and learned features to compose or generate new pieces of music. Several deep learning models are commonly utilized for synthesis and generation, including long short-term memory LSTM models, transformer models, and generative adversarial networks (GANs). These models are particularly suited for music generation and synthesis due to their ability to handle sequential data. LSTMs are capable of learning long-term dependencies such as melody and rhythm, which generate music that is coherent and consistent with the evolving soundscape. Transformer models are capable of weighing the influence of varying parts and sequences of music, focusing on different aspects, such as thematic elements and harmony. Finally, GANs are capable of generating and synthesizing musical pieces that are undistinguishable from real musical pieces conducted and played by humans. Finally, recommender systems are sophisticated algorithms that analyze data to suggest items that are most likely suited for user preferences and needs. AI-driven recommender systems have been deployed to recommend personalized therapeutic music that is tailored to patients' needs during therapy sessions. These systems consider not only music preferences, but also their emotional and psychological state. AI-driven music therapy applications include generation and synthesis, classification, personalized recommendation, as well as monitoring and evaluation of music therapy. In this section, we analyze AI applications in music therapy present in its existing literature. In terms of physical disorders, music therapy focuses on reducing or treating the effects that hinder the quality of life, following our sample generative methods proposed in the literature. Several research work have proposed methods for music generation for tinnitus music therapy. An example of such is an automated method for therapeutic music generation for music segments using LSTM model. The proposed method utilizes short therapeutic music segments and elongates them into durations suitable for treatment sessions without repetition or deficiencies. The LSTM model extracts the melody, predicts the initial pitch, pitch sequence, and pitch trend of the music segments to generate the elongated therapeutic music. Moreover, the proposed method adapts the therapeutic music based on individuals' music style and preferences. In another study, other work proposed a music synthesis approach based on LSTM and transformer structure. The proposed method uses musical instrument digital interface or MIDI technology to generate personalized, unrepeated therapeutic music. The LSTM extracts, analyzes, and synthesizes therapeutic music to suppress tinnitus. In terms of mental and cognitive disorders, the majority of the reviewed research focuses on treating a variety of distress, anxiety, depression, sleep, and cognitive disorders. The majority of the generation methods are dependent on the current musical note for generating the next note, producing disharmonious results, following our sample generative methods proposed in the literature. One of the research work has proposed generative method aimed at relieving stress during music therapy sessions. The proposed method is based on a multi-think filter to produce accurate musical notes, reducing noise and randomness, and a transformer model for synthesis. This approach guarantees that the produced music is harmonious and conforms to musical rules. Furthermore, other musical approaches utilize an LSTM model for therapeutic music generation and classification for specific treatment scenarios of psychological stress. The proposed method deploys a multi-voice music generation algorithm that utilizes varying music features and representations. These methods target these stress and cognitive functions. To tackle a wide spectrum of sleep disorders, other methods propose generating sleep therapeutic music. The proposed method utilizes a GAN model to generate sleep music, similar to ones designed by sleep therapists. The GAN model extracts musical and acoustic features such as articulation, energy, spectrum, rhythm, bass, and treble, as well as noise or tone-like features. Music classification is an essential task in music therapy support, which is commonly associated with generation and recommendation. Usually, classification approaches consider melody, tempo, or lyrics. For instance, some methods propose a lyrics-based classification method using emotional and valence features for music therapy. The proposed method performs morphological analysis on the music lyrics and clusters the extracted emotional cues for classification. In addition, other research work proposed a method for therapeutic music classification that utilizes an LSTM model for classification based on expression methods of multi-part music. The proposed method performed music classification and synthesis to generate different classes of therapeutic music. Moreover, other methods discuss the use of AI in Chinese therapeutic music based on the five elements theory that links human physical and mental health with nature and music. Different tones evoke different emotions, which are used in varying combinations to create music targeting varying illnesses and disorders. Some approaches discussed in this paper deploy machine learning models for classification of five elements therapeutic music based on emotional insights. Other approaches deploy machine learning models to classify or predict whether specific songs are suitable for the desired therapeutic effect. Personalizing therapeutic music recommendations is crucial for enhancing the effectiveness of music therapy sessions. Personalization involves tailoring the selection of music to individual needs, preferences, and therapeutic goals. Recommendations are either personalized based on the patient's preferences, emotions, or biometrics such as heart rate and ECG signals. For instance, some methods propose an AI-based recommender system for music therapy aimed at treating depression and anxiety disorders. The proposed method utilizes ECG signal readings to recommend therapeutic music based on the patient's emotion. The proposed method combines physical activity through an immersive game platform with music therapy. In addition, some approaches utilize the emotional state through face emotion recognition for recommending therapeutic music. The proposed approach aims at improving the sleep journey of college students through personalized music therapy recommendation. Finally, other approaches recommend therapeutic music based on biometric signals like heart rate. This method recommends therapeutic music of different types and tempos, aimed at relaxing or energizing the patients during therapy sessions. The proposed method deploys machine learning models for providing recommendations through a mobile application. Finally, monitoring the progress of patients and evaluating the efficacy of therapeutic sessions are essential in the process of music therapy. Hence, several research works propose monitoring and evaluating methods that automate these processes using AI techniques. For instance, some methods propose an AI-based automated method that monitors the patient's physical condition in real time and evaluates the efficacy of the session. The proposed method utilizes emotion cues through speech emotion extraction. Moreover, some methods evaluate music therapy sessions for terminally treated children. The proposed method utilizes computer vision to analyze patients' face to estimate heart rate in real time to assess the emotional state of the patients during the sessions. Other methods monitor body parameters or biometrics in real time to automate patient assistance during therapy sessions. The proposed method utilizes biometrics such as blood pressure, EEG, EMG, and ECG signals, as well as pulse oximetry to assess the mental state using an artificial neural network. For the accessibility, the proposed method provides a user-friendly interface through a mobile application. Despite the huge advancements in AI applications in music therapy, there are some challenges that highlight the need for careful consideration and responsible use of AI in music therapy. Challenges include ethical concerns about AI-generated music ownership. AI techniques should aim to support and enhance the creativity of music therapy processes. Moreover, there is more room for improving the accessibility modes of therapy sessions. Possible future directions include integrating AI and VR applications to create immersive environments that enhance the accessibility and experience of therapeutic sessions. Furthermore, understanding human AI collaboration in music therapy through co-design with therapists is an area of active research. Finally, future work also includes proposing methods aimed for music therapists' use to enhance the quality of therapeutic sessions and automate the administrative and expert intervention. In conclusion, music therapy is a promising non-invasive intervention that utilizes varying structures and types of music to treat physical, mental, and cognitive disorders. Music therapy has become a widely accepted and active area of research, and recently, AI has been integrated to enhance the quality of the varying stages and processes of music therapy. As seen in this work, AI has been mainly deployed to enhance therapeutic music generation, classification, recommendation, as well as monitoring and evaluation. Applications of AI remain an active area of research with varying promising directions.